I want to give you kind of a brief overview and an introduction to interval notation. Several of you have expressed that you were having difficulty writing your answers, especially to the linear inequalities and the polynomial and rational inequalities in interval notation. So I want to kind of give you a quick overview. Basically, with an interval notation, what you're trying to do is you're trying to express a range of values or numbers in a shorthand notation format so that you don't have to actually list out every single number that could be used, which is virtually impossible to do anyways. So when you express an interval, you really kind of have, I guess in a sense, 5 parts. You have a beginning number. What number could you begin using? And typically this is going to be the smallest number that's possible. You always want to read it left to right. We then put a comma, and then you have an ending number to show what number you're going to stop at or on, and that is typically going to be the largest because you always want to list it smallest to largest. If you're looking at a number line, you would read it left to right, just like we read anything. Then you can have either at the you can use either at the beginning or the end. You can either use a parenthesis or a bracket. And it could be that the bracket's first and the parentheses last. You can have 2 parentheses or 2 brackets, and we'll take a look at how do you know when to use which one. But let's talk about when would you use the parenthesis, which is the curved line. Okay, so the parenthesis is used whenever the number, your beginning number or your ending number, whichever end it's on, the number can not be used in the equation or the inequality. And typically, this would be if you have the inequality symbols less than, greater than, or not equal. On the other end, or you could have it at the beginning, you could have the bracket. The bracket is the squared off symbol. Okay, so with the bracket means it's the number can be used in the equation or the inequality. And typically, when you think about what symbols would be in the problem, you would have either less than or equal to, greater than or equal to, or possibly just equal. The other thing that you need to know about interval notation is our number system goes on forever and ever and ever. Our numbers get larger and larger and larger and larger and larger. And so for the word we use to describe that is infinity. And typically, if we use just the word infinity, we're implying it's going forever and ever in the positive direction. If you want to refer to it so that it's going in the negative direction or is below 0, we would use the phrase negative infinity. The symbol for infinity mathematically kind of looks like a sideways 8. For negative infinity, you would simply add the negative symbol in front of the little sideways 8. Now, infinity, here again, you got to think about it. When you write or think about the number infinity, there's not a mark on the number line where we say, boom, here's infinity. Okay? And so infinity has that connotation or the idea that it keeps going on and on and on. So it is what we consider open-ended. So it should always get a parenthesis for infinity, whether it is positive infinity or negative infinity. You want to always use the parenthesis when you're writing the interval notation. So I want to do you some examples, and I want to try to show you what it would look like if it's written kind of in an equation form, what it would look like on a number line, and then also what it would look like in interval notation. So hopefully you can make a connection between perhaps what you already know and then kind of this new shorthand notation. So for example, let's say that we want a value, we want x to be between, let's say, -2 and 3. Symbol wise, that's words. In symbols, we would write -2 is less than x is less than 3. If you visualize that on a number line, and your number line doesn't have to be perfect, we know 0 would be in the middle, -2 would be to the left, and +3 would be to the right. And both of these are between, but it doesn't say I can include them. So visually what that means is I want to show that I'm going to go from -2 to +3, and I can use any value in between, which means I could use -1, 1, 1.5, 1 3/4, 2, 2 2/10, 2.5. Okay, so I could use any value in between there. So interval wise, again, thinking about it and working left to right, I'm going to begin on the left at -2, comma, I'm going to end at +3 on the right, and I can't include either of those, so I have a parenthesis on the -2 and a parenthesis on the 3. Now, you do have to be careful because some of you may think, well, Mr. Austin, that kind of looks like an ordered pair. You have to pay attention to the context to make sure that whether or not it's an ordered pair or whether it is interval notation. So let's look at another one. Let's say we wanted to do between and including, and let's go -3 and +1. Okay. It doesn't matter what numbers I use there. These are just examples, and I'm just making them up as I go. Okay. So again, thinking about it on a number line, I would begin in symbols. Let me write this in symbols for you. Here again in symbols, this time it says I can include it. So I would have from -3 less than or equal to x, which is less than or equal to 1. It's including, which means I can actually use those values. So again, I'm going to put those on the number line. Again, it doesn't have to be perfect. We know 0 is kind of in the middle. We would have -3 on the left, +1 on the right. And this time when I draw the picture, because I can actually use those values to show that I can use them, we color in the dot. You want to think about it, it's sort of like a manhole. If you can use it, the manhole cover is on so that you could actually stand on that number on the number line. But if it's not included, then the manhole cover is off or it's open, the dot's not covered, and you would fall in. And then we can do any value in between. So writing this as interval notation, again, we always work left to right. So we would start at -3, go to +1, and then we would have brackets on either end because the values are included or can be used. It's also possible, okay, that you might have something, and I'm just going to use the symbols here, where you maybe have something like -2 is less than or equal to x, which is less than 3. Okay, so that one endpoint is included and the other endpoint is not included. So here again, if we think about that on a number line, in the middle you have 0, you have -2, +3. Visually, when you draw it on the number line, the 2 can be used because of the equal bar. So we would have a shaded in or a colored in dot. The 3 is not used, and so it would be open, and we want values in between. So thinking about that in interval notation, we begin at -2, comma, we end at +3. The 2 is included, so it gets a bracket. The 3 is not included, so it gets a parenthesis. And let's see. Then you could have something like -3 is less than x, which is less than or equal to +1. You have the other endpoint included. Instead of the first one, you have the second endpoint included, and it can be any which way. So let's say I have horizontal number line, 0, -3, +1. Visually, when you draw it, the -3 is not usable, so it's going to be open. The +1 is usable, so it's going to be closed or colored in. And then it's any value in between. So again, working it out as intervals, starting from the left and working to the right, we would have -3, comma, +1. The -3 is not used, so it's a parenthesis. The +1 is used, it's a bracket. Okay, so these are called closed, well, not really closed intervals, but these have a beginning point and an ending point. But sometimes you have an expression like we might have the expression that maybe, let's say, it's less than 4. Okay, so in symbols, that would be something like x is less than 4. So we think about it in terms of a number line. That doesn't necessarily give us an idea of where it ends. It just says I can use anything less than 4. Well, less than 4 could be 3 or 2 or 1 or 0, but it could also be something like -100 or -1,000. So it has that idea, and it may help you again to see it visually, that it's going to go on and on forever in the negative direction, the idea that it's less than. So 4 is not included, it's less than, so we can't use 4 exactly, so we use the open dot, and then we want anything less than that, and less than is to the left. And again, the idea is that this keeps going on forever and ever and ever to negative infinity. Okay, you can't really put that on the number line, but that's what happens. So as you think about writing it as an interval, starting at the left, you're actually starting at that kind of unusual value of negative infinity, and you can go all the way up to +4. The +4 is not included, so you get a parenthesis. Negative infinity always gets a parenthesis because of the idea that it does keep going on forever and ever in a particular direction. Similarly, you could have something like we want x to be less than or equal to, say, 2. You want it to be less than or equal to 2. Symbol-wise, you would have x is less than or equal to 2. Again, if you think about the number line, and I'm making them up as I go, remember. Again, I can choose anything that is less than or equal to 2. So in this case, I could actually use 2. I could use 1, 0. I could do -10, -50, -100, -1,000. Okay, so again, it has the idea here that it does keep going on forever and ever, in the negative direction. So because I can use the 2, we color it in. The dot is colored in or covered, and then we want anything that is less than that, which would be to the left. And again, that gives us the idea that it keeps going on forever and ever and ever in the negative direction. So again, when you write your interval, be careful because we work left to right. Okay, so we would start at negative infinity, go up to positive 2. Positive 2 can be used, so we use a bracket, but negative infinity gets a parenthesis. Infinity or negative infinity always and forever gets a parenthesis. You could have things like greater than. Let's do greater than, let's say, -3. Again, and it doesn't matter what the number is. I'm just making them up as I go. So this would be something like x is greater than -3. So if we look at it on a number line, okay, this tells me I want to choose anything greater than -3. So I could use things like -2, -1, 1, 5, 10, 100, a bazillion. Okay, so again, it has that idea or that sense that it's going to keep going on forever and ever to the right or in the positive direction because it's greater than. We cannot use -3, so we use the open circle and then the arrow goes to the right, and that implies that it goes to positive infinity. So again, writing it in interval notation, working left to right, we would start, in this case, at -3 and go to positive infinity. We cannot use -3, so it gets a parenthesis, and infinity always gets a parenthesis, again, because of the idea that it keeps going on forever and ever and ever. You could have something such as greater than or equal to, say, -1. Okay, so this would be x is greater than or equal to -1. There it is in symbols. Think about your number line. In this case, it can be equal to -1, so we could use -1, 0, +1, +5, 10, 1,000, a bajillion. So again, it has that idea that it keeps going on and on and on in the positive direction. We can use the -1, so my dot on the number line would be colored in, and again, it would move to the right, implying it's going to positive infinity. So writing it in interval notation, we begin at -1 on the left, we continue to positive infinity. -1 can be used, so we use a bracket. Infinity always gets a parenthesis. One other one that you sometimes see as we progress on throughout the course that you're going to run into is the idea that x can be all real numbers. The idea that it's all real numbers means it could be any number that we can see, we can touch, we can hear, basically any number that's on the number line. So when you think about the idea that x can be all real numbers, we're basically saying it can be any number on the number line, which means it could be anything from negative infinity up to positive infinity. And so the phrase or the idea of all real numbers in interval notation is written, we go from negative infinity to positive infinity. And again, in both cases, we have parentheses for those. So I kind of hope this explanation helps you in terms of becoming familiar with interval notation, when to use a bracket, when to use a parenthesis. And then we'll take a look at some other examples of the linear inequalities in a separate video.